It is 11 o'clock in Vienna, in Oslo, and here in Stockholm. My name is Martin Gias. I'm the head of Advantage Austria Nordics. I'm based here in Stockholm, and I'm very happy to welcome you all to our webinar on batteries and e-mobility opportunities, trends, and challenges. We're going to tackle questions related to battery technologies with a focus on e-mobility in the next 90 minutes. And we have managed to put together a very exciting panel. You see the faces of all our speakers there, and I hope technically it's all going to work out as planned. Before I introduce the speakers in detail, I would like to thank my colleagues Peter Mangli and Eike Simons from our Oslo office. They have managed to put together this webinar, and if anything goes wrong, blame them. If everything goes well, it's all of us who have contributed to it. Anyway, very happy to have a very interesting panel here. We will start later with Sulalit Bandyopadhyay. Sulalit is an associate professor at the Department of Chemical Engineering at the Faculty of Natural Sciences at the Norwegian University of Science and Technology. Here you can see the rundown of our speakers. Sulalit will give us insights into the electric vehicle battery recycling technologies developed in Norway. He will be followed by Kai Just Olsen. Kai will see things from a practical side. Kai is the managing director of ASKO Maritime. ASKO is the largest food distributor in Norway, the 6th largest Norwegian company. He will talk about exciting things just as sea drones, for example, and shed some lights on the electrification along the transportation chain. So a focus on the logistics and electrification. Kent Torrison, our third speaker, has put the title Powering the Future on his presentation. He is the founder and chief officer in charge of innovation at Rebel X, Hagal, an Oslo-based company which has developed a whole system which serves at enhancing the life of batteries. So we don't just throw away batteries, but we reuse them. And I think there is a very, very interesting technology which Hagal has developed in this context. And last but not least, we have Frida Gullum Brewer, senior research scientist of the Department of Thermal Energy at SINTEF, based in Trondheim in Norway. SINTEF, you might know, SINTEF is one of the largest independent research organizations in Europe. So that's the rundown of our speakers. You can see all of them are from Norway, and that is not a coincidence, since Norway is investing a lot of resources into electric vehicles, into battery technologies. So I think it certainly makes sense when we talk about the vanguard of battery technologies to listen to what our colleagues in Norway have to say. Before we start, though, a few technical points. So this is a live event, so bear with us if things go wrong. We've planned very meticulously for this webinar, but nevertheless, if there are glitches, our apologies. This is a live webinar. Although we will record the webinar, you will later on receive a link with a path which leads you to YouTube, where you will find a video, so you can look again at this webinar. You will also receive an email with the slides, which we are going to show to you during the next 90 minutes for you to go through them again. And one important point is that there will be an opportunity to ask questions, not after each presentation, but at the end of the webinar. For this, please type your questions into the chat function of this webinar platform. So you have to ask your questions in writing, And after the fourth presentation, we will gather all those questions, group them, and I will have a chance then to moderate the Q&A session, as I said, at the end of this webinar. I will now hand over to my colleague, Peter Mangel, who will introduce speakers and the presentations one by one. Peter, the floor is yours.
Well, thank you, Martin. Thanks for the very good presentation as well. So I think there's not much to say. First speaker now, Sula Litt. For the next 15 minutes. As you mentioned, he is the Associate Professor at the Department of Chemical Engineering, the Faculty of Natural Sciences, at the University of Technology, NTNU, one of the leading universities in that field. He hails from Trondheim, and the floor, Sula Litt, is yours. You will be talking about battery recycling in Norway. So the next 10-15 minutes, please go ahead.
Thank you, Peter, and welcome everyone to this webinar, and good morning for people watching us live. So I'm going to talk for the next few minutes on giving you a broad insight into the electric vehicle battery scenario in Norway, and mostly in regards to recycling. So I'm an associate professor at the Department of Chemical Engineering, where my main role is within particle engineering and hydrometallurgy. And in the second aspect of it, which is then hydrometallurgy, we are an established group working towards battery recycling, specifically electric vehicle battery. And before I go into the topic, I thought I would tell you very quickly how I've structured today's talk. So we will know a bit more about the state of the lithium battery recycling, some of the challenges involved, and then introduce you to some of the ongoing projects, opening up for possibilities of networking later on. So I'm hosted at the Department of Chemical Engineering here at the Norwegian University of Science and Technology, which is a department with a high focus on research in general. We are more than 100 PhDs, postdocs, and researchers that are regularly working on a wide range of topics. The Department of Chemical Engineering has a vision for sustainable process solutions, which is where the battery recycling work that we do here fits in very nicely. This is a premier institution educating students across Norway in chemical engineering for both the Norwegian and international industry and academia. And within the scope of sustainable process solutions, the department is structured in 4 different research groups where we work both from the lab scale to industrial productions. We work with very tiny molecules and we make particles, and these particles are then, in a very typical operation, goes into a reactor system, a column, which can then handle different chemistries, different processes. And we also look at the overall process plant optimization. So the research scope ranges from tailoring particles at the nanoscale to optimizing big pilot plants and process plants using a mixture of experiments and theoretical modeling. With that typical background in mind, I would then like to introduce you to the titled topic of lithium battery recycling. Now, as one can think of batteries, electrical vehicle batteries, that they are in general built for a lifetime of 8 to 10 years. And when we look at the whole battery scenario within a circular economy and sustainability framework, recycling is probably not the first option. So I just put up this waste management hierarchy, as you can see now on your slides, where probably usage of materials that are good for the environment, that's a prevention step. And then comes the reuse part, where when your battery has reached the end of life in around 8 to 10 years, can you reuse or repurpose those batteries for something different? But where we come into the picture in this whole hierarchy is about the recycling process, and that is mostly then to tear down the battery and recover the different components either in forms that we can directly use for battery manufacturing or into components that can go into other processes. So in an approach to close the loop. And there are two important challenges when you talk about the reuse challenges, is that if you are thinking of reusing huge volumes of end-of-life batteries, there is of course a storage problem, because some of these batteries are often not safe to store in the conditions that they are in, and their compatibility for a large number of secondary use, as we'll probably hear later on in this webinar, are also quite limited in terms of research potential. What we think, and our reason for going into lithium battery recycling, is that many of the resources which are currently used for the battery cathode and battery anode manufacturing, there's a scarcity of resources and of course unequal wall distributions. Currently, the lithium from these lithium-ion batteries is not recovered in an industrial setting, and this could also have less environmental impacts if one can approach that. And there is always the cobalt, which is an important component then of the battery cathode, has ethical and environmental concerns regarding mining, etc. So there are strong grounds why lithium battery recycling should be taken up as an important topic, and is taken up as an important topic now for both research and industry. And these are just some numbers projected from the Norwegian market, which has an increasing trend of the annual sales in this plug-in electric vehicles, so both the plug-in hybrids and the electric vehicles. And as you can see, that driven by the Norwegian government's regulations and also wishes over the coming period, one can see a very steady rise of the BEV share in the market. And this is also good then for the recycling business. And the majority of the recycling has been dominated by these battery directives, which is another reason of to meet the target set by, for example, the Battery Directive 2006. A more recent addition to the recycling legislation is a Directive 2012-19 regarding end-of-life vehicles, which has stipulated reuse and recovery rates to be increased to at least 85% with regard to the weight per vehicle and year. And of course, how this recovery percentage is calculated depends quite a lot on how one intends to do it. But the major challenge is that in a mostly adopted recycling processes, which is still based primarily on pyrometallurgy and some in hydrometallurgy, where pyrometallurgy is high temperature treatment, and you basically put this used batteries into a furnace, and some of the valuable metals and elements then end up in the slag. It's difficult to recover. On the other hand, when we take up hydrometallurgy, which is then water-based processes, also results in huge volumes of wastewater that needs to be treated before they can be discharged. So there are pluses and minuses, but in the pyrometallurgy processes, the way you close the mass balance will also affect what you recover at the end of your process. And these are also some numbers to show that both not only in the EU, but also in other China, which is one of the leading users of batteries and producers as well, there is an increasing trend, but just be careful of the numbers or the volumes that we're talking about is widely different when we compare the EU to China. But this all data prove that there is a market for recycling. The other thing that recyclers think about is not only the volume, but also the metal values. And if you look at this very schematic, you see that some of these metals, for example, cobalt and lithium, they have literally higher values. But the other metals, for example, nickel and aluminium, these are some tentative numbers which also change as a function of time. But on this analysis, it's based on a typical average of different battery cathode chemistries, NMC being one of the most popular, LFP and LMO being ones which are in use currently. And this shows that it's not a very bad market. But if you try to look at it from a value perspective, then cobalt is kind of on the top of the list, followed by lithium, and then the rest of the metals. And this is also a driver then why most of the processes that exist in the industry have focused on recycling of cobalt specifically, and some nickel and some manganese, but not so much on lithium, which is also a light metal, just for information. So with that background, I would like to take you to some of the current challenges very quickly. There are challenges in battery pack disassembly, volumes of LIBs, as I mentioned about the capital cost for pyrometallurgical routes. The battery design and the battery chemistry is fast evolving, and it's very difficult to develop a single method that would be able to feed in all the different types of batteries, do a one-way process. It's not yet available. And there is, of course, a lack of better sorting technologies. So if the batteries could be sorted based on design, based on volume, based on chemistry, maybe that can help recycling downstream. And one thing that I would like to specifically stress upon is that there is a lack of design for recycling. And so when battery manufacturers and car manufacturers, they give inputs for the type of the design, recyclability is not still on a very high priority. But for recyclers like us in the academia and working very closely with a bunch of industries, this is a very important aspect. So then I will take you very quickly on the 3 projects and just mention the scope of work that we do. So the first project is then LIBRES, which is a national project. And as you can see on your screen, there is a large number of industrial actors present in this consortium. The main goal of the project is to develop a design basis for an LIB recycling pilot plant in Norway. Hydro is the project owner. And what we intended to do in the project is that the pilot plant should be large enough to handle commercial volumes in 2024. But the project and the momentum that it had gained has already resulted in the formation of a joint venture between Northvolt and Hydro, which is called the HydroVolt, that has already started operation in its testing phase now. So the main idea within this project and where we come in is to then use this the hydrometallurgical routes after the cells have been deactivated and dismantled to do some physical separation and mostly a chemical separation to provide streams that we won't treat to the final elements, but will give it to the existing industrial customers who would then put it into their loop. So that was the ambition in LIBRES. The ALBATROSS project, which has started now, has the need and of also thinking about design and making smart batteries. And here we are looking at the European electric and hybrid electric passenger vehicle market, where we are trying to reduce weights, high energy densities increasing, ranges, faster charging time, but also on recycling and reuse. And that is where our role as NTNU comes in. As you can see, it's a mixture of different companies along the battery value chain spread all across Europe. Our role here is again to look at dismantling, recycle, and how we can design and implement these processes in a pilot scale setup. The final project that I would like to bring your attention to is an internal project funded entirely by NTNU that was granted last week, where we are looking at developing a holistic ecosystem for sustainable both repurposing and recycling of LIBs in Norway and in EU. And here we are going into understanding and developing sustainable business models for the whole battery value chain. And our focus is on specific lithium recovery and graphite recovery, and develop a process that can take in different battery designs and chemistries without compromising to the cost and the environmental side of it. With that, I would like to thank all of you for listening in. And if you're interested to learn more about our research, you can visit the webpage. Thank you for your attention.
Thank you so much, Sulalit. Super interesting presentation, of course. We're talking about all the challenges also within the battery recycling sector. We will leave the research field behind now, and I will hand over to our next presenter, who is the Managing Director of ASKO Maritime here in Oslo. ASKO is the largest in Norway and also part of Norgesgruppen. Norgesgruppen being the 6th largest company in Norway, so big player. And he's going to talk about the 100% battery electric transport chain, a super new exciting project. As we did when we first heard about it. So Kai, if you would like to take over the next 10 to 15 minutes.
Thank you. We can start. I'm Kai Stolsen. I'm the director in ASKO Maritime, and I will give you a picture of what ASKO are doing, especially when it comes to battery and electricity. As it's mentioned here a few times, Norgesgruppen is Norway's largest food retailer, and it's country's 6th largest company. Norgesgruppen has 44% market share in the grocery market in Norway. ASKO is a wholesaler, logistics and distributor for the Norgesgruppen and covers the whole country with 13 regional warehouses and 700 trucks on the road every day. ASKO Maritime is part of ASKO and established in June 2020. The business idea is that ASKO Maritime will be a leading player in the development and provider of zero-emission sea transport to promote sustainable and innovative logistics solutions. ASKO Maritime's first investment is a zero-emissions transport chain with 2 vessels, sea drones, with full electric operation and unmanned. ASKO has 13 warehouses located at the largest market areas in Norway. In addition to the regional warehouses in Vestby, on the east side of the Oslo Fjord, there are 2 automated central warehouses in the same location, a shield warehouse and a dry warehouse that both supply all the regional warehouses. ASKO is currently opening a new large automated regional warehouses on the west side of the Oslo Fjord. ASKO produced approximately 90 gigawatt hours in ASKO's own wind turbine parks. ASKO has installed approximately 90,000 square meters of solar panels on the roof of the most warehouses. These deliver between 12 and 13 gigawatt. With these wind turbines and solar panels on the roof, ASKO produce more renewable energy than what we are used today. The current energy consumption is in the ASKO companies will be reduced further 20%. Our goal is 100% emission-free transport by 2026 using battery electric, hydrogen electric trucks. Until electricity and hydrogen electric technology are commercially available, we use biodiesel, biogas and bioethanol. ASKO sets high goals of being 100% emission-free transport by 2026. ASKO also produces green hydrogen for its hydrogen trucks. ASKO has ordered the first 75 electric distribution vehicles and charging stations for all our regional warehouses. The ongoing project I work with today is establishment of a full electric transport chain with electric sea drones, electric terminal tractors and electric 50-ton trucks. ASKO is today self-sufficient in clean electricity, but the phasing in of electric trucks and electric sea drones requires that we increase production. The reason why ASKO is establishing its own ro-ro vessel, sea drones, crossing the Oslo Fjord is that ASKO is establishing a new regional warehouses on the west side of the fjord and has 1 large warehouses on the east side of the fjord. ASKO will have 150 crossings every day by 2030. Establishing a climate-neutral transport chain with battery electric trucks and vessels and achieving good logistics and economy is ASKO's goal. Trailers are transported between warehouses and ports by battery electric trucks. Trailers are transported without trucks and drivers across the fjord. The vessel will be unmanned and autonomous terminal tractors will load and unload the vessels. In this way, efficient use of trucks to drive is achieved, and we reduce number of trucks and drivers to transport the same amount of goods. In ports and warehouses, charging infrastructure is established where reuse of car batteries in the battery bank is a part of the solution we try to come to. I will now show an animated film that better explains our innovative project before I leave to Hagal to present the solution for reusing car batteries in a battery bank using Rebel technology. Thank you.
ASKO, the largest grocery distributor in Norway, has warehouses on each side of the Oslo fjord. In a few years, 150 trailers will move between these warehouses every day. Today, the trailers are transported by diesel trucks on heavily trafficked roads with frequent disruptions. ASKO is now establishing an innovative emission-free transport system. Trailers will be transported by electric trucks and cross the fjord on battery-driven autonomous vessels. Trucks bring and pick up trailers from port. Terminal tractors equipped with Red Rock's autonomy solution pull the trailers on board. Trucks and terminal tractors charge at ABB charging stations supported by Hagal battery bank made of reusable car batteries. Masterly's certified operators ensure a safe and efficient fjord crossing with the unmanned vessel. They're working from a remote operation center equipped with Kongsberg Maritime's world-leading technology. In port, the vessel moors and charges automatically. Drivers can efficiently transport trailers between pickup and delivery points in a complete emission-free transport chain. To achieve its goals of climate-neutral transport and reduce mileage on congested roads by 2026, ASKO has found a way to enable emission-free supply of food to your local store. Welcome to a greener shopping experience.
Thank you so much, Kai. You might already have seen the company Hagal as the founder in this short video. They're the next who are going to present, the Chief Innovation Officer, Kent, who's going to talk about powering the future and the Rebel X project. So Kent, if you would like to take over.
So Hagal started because we took a close look at what does it actually mean to electrify everything. If we are to keep up our commitments in regards to climate change and cutting out fossil fuels, our only option is in reality sun and wind and electric energy. But if you start to calculate the numbers, what that actually takes in practice, you quickly run into a few major hurdles. One of them is that the grid can't actually support that amount of energy transfer. Even in Norway, where we have over-invested in the grid, there is just no way that we can move all the energy currently used via fossil fuels in trucks and boats and planes and so on over to the electric grid in any sensible way. There's not enough hydropower available for that. So that means we also have to build out with a lot of wind and solar, which ASKO is, I think, probably the leading producer of solar and renewable energy in Norway today. So ASKO is very, very far ahead of the curve, but everybody is thinking about this. But if everybody did what ASKO does today, and if ASKO did this for every single truck they have, the grid would get into real trouble, some places worse than others. So Hagal started looking at what do we actually have to do to get around these bottlenecks. And the only sensible solution we could come to was that you have to have distributed energy storage. If you have distributed energy storage, you can transfer the energy during times when the capacity or the load in the grid is low, to then consume a high level of energy locally right next to the battery pack when you need it, without putting so much stress on the grid. So distributed battery systems in the grid would greatly increase the transfer capacity of the grid. It also allows us to actually use variable energy sources such as wind and solar, because they are variable, and the way the grid is built today, consumption and production has to be in perfect balance. And that means if the wind is blowing at night and no one is using electricity, you can't produce. You have to turn your wind turbine off. And the more or the higher the percentage of sun and wind in the grid, the lower the availability to produce when you can in the grid. So we see this in Germany, particularly, where they have a high aspect of solar energy, that when it's a sunny day, the grid is almost collapsing due to overproduction, and it creates a lot of problems. And it's commonly known as curtailment. So by having distributed energy storage, you drastically cut down curtailment, and you avoid the problem of actually having a decreasing return on investment in sun and wind if the percentage of variable energy in the grid becomes too high. So this solves several big project or problems in the grid by thinking in a distributed manner. So think Tesla's megapacks, but at the end of the consumer, so that you can move the load on the grid out in time. Then we started looking at what do we actually need for this to be adapted on a wide scale. And the obvious red flag was, of course, the costs of current energy storage systems. So we started looking at how can we actually cut these? How can we reduce the energy costs? We also started looking at what are the available resources in regards to batteries. And we've quickly learned that there is not enough batteries in production today or planned for production to cover all the buses and cars and boats and planes and everything that we want to electrify, and also cover the needs in the grid, because the needs in the grids will be almost as big as all the battery packs for all the electric vehicles and all the other things that we want to electrify. But if you take into account your used batteries and B cells, then there is more than enough batteries, and it also further drives down costs. So we've redesigned the way you build a battery pack. We've taken many components completely out, made it into a distributed system that can also use B cells and U cells. And if we use U cells, we're typically cutting the cost compared to a traditional battery systems from 75 to over 90% in regards to the actual functional costs at the end. So we lower system costs drastically, and due to the way we have structured our system, we also have a lot less losses in the system. It's very modular. We don't have any kind of traditional DC bus, so it becomes much more robust, meaning that a battery cell can actually break down in the system and it won't affect the system in any meaningful way. It gives us access to low-cost cells. We can get the B cells that the OEMs don't want because it's outside of their specification. This is in some cases up to 20% of the production from a gigafactory. And of course, the used cells. And there's some big challenges that needs to be overcome before you can safely repurpose a battery cell on an industrial scale. Because all of these cells have different state of health and are slightly different. So you actually have to adopt a unique control algorithm for every single cell. And in our experience, on an average EV battery pack today, we can usually reuse 80 to 85% of the cells without any problems, and the remaining 15 to 20% goes straight to recycling. And out of those cells that we reuse, we expect to get another 10 years lifespan out of them, because we have a much more adaptive use ratio. Another important aspect in relations to ASKO is that if we reuse the battery packs from their electric vehicles, from the trucks, we can actually generate spare parts from the used battery packs for other battery packs that also have problems in them. So you actually get first application spare parts and energy storage in the same classification process. So we actually disassemble the entire battery pack and test every single battery. And we have a machine learning mechanism on our systems in many different layers. And this gives us a very, very accurate state of health for every single battery. And as we use the cells, we actually monitor them over time in every single use pattern. So for every battery pack that we get into the field, this algorithm improves. So the system becomes smarter and smarter and smarter. Of course, extending the battery life is probably one of the best environmental actions that we can take, because you've already invested the CO2 in mining the materials, building it, et cetera, et cetera. And it also gives us time for specialists such as the people at NTNU to improve the recycling technology. So by the time the cell actually goes into recycling, 10 years down the line, hopefully we'll be able to reuse even more of it. We don't actually affect the old recycling thinking. We're simply reusing the cells that can be reused. And by using the Hagal technology, we can actually combine cells of different health into one system. So if we have a weak and a strong cell in one pack, we will just put a different workload on each of the cells. And we also have very unique pattern buildings in the pack for discharge and for charge. So we can actually extend the cell life by up to 30% in some of our tests. And this goes for new cells as well. So if this was built into the battery pack to begin with, you would actually not have to remanufacture the battery pack at all. So if a big OEM, Scania or truck producers like that, actually used this distributed control technology, they would get a lower cost on their battery pack, but they would also get 30% longer life in the first application and a built-in second life application use without having to remanufacture the system at all. So you can get multiple functionalities out of the same battery pack by simply changing the software parameters or changing the system's behavior. So we take the traditional system where you have a BMS, an inverter, a charging unit, and so on, and we put it into one set of electronics. This greatly reduces the system cost of the pack, and it also allows us to, for example, run with dead batteries in the system. On top of that, we can use used cells and B cells in one of the sums, one and the same thing. And you also get the multi-function functionality in the electronics to begin with. So if you have a battery with this technology on it, you don't need a DC charger on your wall at home, for example. You can feed this AC directly. There is no problem. You can have one phase, two phase, whatever you want. And when you want to use it or use the vehicle, you can switch the modus of the operation to function as a motor driver. So it's a completely new way of building battery packs. Thank you very much for your attention, and I look forward to getting some questions if you have that later on.
All right, so thank you very much. First of all, thank you for the invitation to come and speak at this event. And I hope some of my information here can be useful to you as well. So I will try and shed some light on the prospects and challenges of electrification in public transport. And I believe some of this has already been shed light on now, especially by Kent from Hagal. So we've heard a little bit about some of the challenges related to electrification of the ASKO trucks, for instance. I will try and elaborate a bit more also on these aspects. But first of all, a little bit about SINTEF. Some of you may know us, some of you may not, but we are, as mentioned previously, one of Europe's largest independent research organizations. We have approximately 2,000 employees from about 75 different nationalities. And we do work with customers from all around the world, between 3,000 and 4,000 different customers throughout the year. In SINTEF, we have 13 different areas that are considered particularly important to us and are deemed as corporate efforts. Batteries is one of these areas, and I am the leader of the battery corporate efforts in SINTEF, so I'm starting to get a pretty good overview of all the activities going on in SINTEF in this area, and we'll try and give you a little bit of info on that as well. SINTEF has a vision, which is technology for a better society. Because we cover such a large area, we work with everything from small SMEs to large public entities, huge corporations, and we have expertise from all the way from ocean space to outer space. So there's quite a few topics that we do research and innovation on. Our organization is split into 6 different institutes, where my institute is SINTEF Energy. We also have some branch companies, which are smaller companies around the country. In addition, we have also an office in Brussels, so we have really good contacts with the European community. The main research areas for SINTEF Energy are, of course, my area, the energy storage, where we work both on batteries, thermal energy storage, and hydrogen. In addition, we have focus on specifically on the systems level, on integrated energy systems, renewable energy production, particularly hydropower and wind, but also some solar. Smart grids, energy efficiency in industrial processes is a big topic for us, in addition to bioenergy and CCS. When it comes to the batteries, because we have activities in essentially all our different institutes on some level, we do cover the entire value chain. We also have collaboration, quite a lot of collaboration with NTNU, as you've seen previously with Sulalit. We also have collaborations there. And we work on everything from materials development to recycling. In addition, we have quite a significant group on multi-scale modeling, all the way from nanoscale to systems level. And of course, the circular economy and feasibility studies, which are more cost-cutting activities, are important areas for us. If you want to know a little bit more about SINTEF, you can also go to this link down here at the bottom, where you can find information about our expertise, our projects, and so on. But over to the topic of today, which is the electrification in the transport sector. As you probably already know and have heard previously today, Norway is one of the countries which has come really far when it comes to electrification. We have a really high amount of electric cars on the roads. In addition, we have a lot of ferries, ships, boats that are electrified. We have buses. If you see the bottom right corner here, these are electric buses that run in Oslo. The ferries on top here are vessels that are on that are running in the different fjords. And I know by the end, like by 2028 or 29, the goal is that all the ferries crossing the fjords in Norway, which are up to 200 ferries, will be all electric or hybrid ferries. But of course, some of these cannot just be all electric. If you look at the big cargo vessels or airplanes or trains, fully electric is perhaps not feasible, at least not yet. And I will come back a little bit to that. I'm not going to spend too much time on this slide because I think Kent in the previous presentation, he shed some really important light on this topic with the challenges related to electrification. And especially what he mentioned with the grid challenges, the power demands that will be necessary if everything's going to be electrified and be charging at all times. So I believe that we will see a lot more of these smart distribution grids containing Hagal's batteries or other systems as well. I think that will be part of our future energy system. And a little bit of fun fact is that in August 2021 in Norway, 72% of all new cars sold were fully electric. So we're getting to, and in the same month, also all the different counties in Norway were above 50%. So we're getting a really high percentage of EVs on the road in Norway. It's all right. Next slide. Nope. Ah, there we go. Oh, too far. Sorry about that. So current lithium-ion battery technology, Sulalit mentioned some of this already, but the main chemistry that's being used today is the NMC, which is the nickel manganese cobalt oxides. In combination with graphite anodes and also the liquid electrolyte, which is the culprit in our system causing a lot of issues. These batteries require quite strict safety measures. There's electronic sensors, cooling systems, which take up a lot of space. We see that the energy density is still too low for larger vehicles, ships, trains, and airplanes. And if you look at the top right corner here, the green oval, this shows the energy, gravimetric and volumetric energy densities of the current lithium-ion technology. Also, frequent fast charging is an issue. And of course, what we don't want to see is the bottom picture here with a car catching fire, or even worse, a big ship out at sea catching fire, or bigger things. Some of the limitations, of course, is one thing is the energy density, but also the safety. With the current technology, we can't really completely get rid of the hazards of the electrolyte. But new solutions are coming up for the anodes with the silicon. We also see some quite significant improvements on the battery system, because if you look at a battery, the energy density is only the energy stored in the battery cell itself, but there's a lot around the battery with the battery management, the cooling solutions. So by increasing the compactness of the system, we can significantly improve the practical energy density of the current systems. But the figure to your bottom right here, if you look at the dotted line, this gives you the approximate theoretical limit of the current graphite layered cathode couple. Some of these chemistries below here are the currently available chemistries that are on the market. But another curiosity that I wanted to show, and it's a figure that I came across earlier this year. It's because often I hear that batteries are, why aren't batteries evolving like other electronics? And we see so many other things improving so quickly. And batteries, they tell me, oh, they're so shitty. They're not, you know, we have to charge it every day. But if we have a look at, if you look at the battery, the first lead acid batteries came around 1860, and you see at the bottom here, if the batteries were to follow Moore's law, by 2021, a Tesla semi-truck battery pack would equal to a Type 1A supernova. So, and we all know that that's quite impossible. So the batteries are evolving at their own pace, and we can't really compare it to other technologies in electronics. The actual battery energy evolution since the 1970s is around here in this little dotted rectangle. So, but what about the solid state batteries? Many of you have probably heard about the solid state battery, but don't necessarily know what that means. Now, the solid state battery, what it means is that you take out the liquid electrolyte from the current technology and you replace it with a solid or a semi-solid electrolyte. You sometimes, to some extent, can use the similar electrode materials, but also the promise here is to also be able to use lithium metal for the anode. These batteries have, because of the solid electrolyte, which is non-flammable, the risk of fire and explosions are drastically reduced. It can also operate at much higher temperatures, so the cooling systems that are required today will not be as extensive. And of course, significantly improved energy density. The batteries can also withstand fast charging and handle much rougher conditions. Still, even with those improvements, I think we will still see a lot of hybrid systems, especially for cargo ships and long distance flights. But what is the market readiness of solid state batteries? This is also a question that comes up quite often. I've found some more recent publications from different companies, some that really believe in the solid state batteries and claim that they have breakthroughs, others like the Henrik Fisker that believe in the solid state batteries but have now dropped that technology and goes for the conventional one. Then you have the Daimler that published an article in February saying that they have delivered just first solid state battery buses in Germany. And I'm gonna come back to Toyota on the next slide, because they claimed back in 2019 that in the Tokyo Olympics they would launch their first fully electric vehicle based on solid state batteries. Now, they actually have kept their promise, and last year they launched their first fully electric vehicle with a solid state battery. So they do have a prototype running, and I'm quite excited to see how quickly this can become mass produced, because that's another question, how fast this can become a mass production and at a reasonable cost. I also want to mention, this is not necessarily the solid state, but it will certainly be enabled through solid state, because in Norway we have Widerøe, the airline, which operates most of the short haul flights in Norway between the small towns. They have now joined forces with Rolls-Royce and Tecnom to launch the first all-electric passenger aircraft by 2026. It's supposed to fly between Stavanger and Bergen in Norway. And their goal is to achieve net zero emission by 2050. You can read a bit more about that as well on their websites. And finally, which was also mentioned briefly earlier, and I think if we're going to be able to realize all the promises of the batteries and the electrification, we do depend on a good EU battery regulatory network, because it's so many things are still expensive, like we've heard from the recycling, and many things and costs are driving so many of the developments. But the first draft of the new EU battery regulations came in December of last year, and the new regulations are now also being revised as we speak. These will address many of the topics that I've listed here, and I'm going to read up all of these. You will have access to these slides later, but especially the recycled content, performance, durability, and also the second life comes into this. So I think there's a lot of important issues that will be addressed, that will be determining how EU and Norway as well will be implementing batteries in the future. So to sum up, I believe that battery properties are constantly improving, but we still are going to need the hybrid systems. Solid state batteries are coming, and they will make a big breakthrough once they can be mass produced. I think we will still see challenges with charging infrastructure, energy power supplies, and in order to solve many of the resource issues that we see, second life and recycling will be key to the future of electrification. And also the battery regulations are going to be a big important step for us. So with that, I want to say thank you for your attention, and I hope I can answer some questions afterwards. Thank you very much.
Thank you, Farida. Yes, it is question time. We have very exciting presentations. Just to sum up again, questions concerning the recycling of batteries were tackled, as well as the reuse of batteries, the application of battery technologies in public transportation. Thank you, Farida, for your contribution. And of course, also the integration of electric vehicles into the logistics chain. We have received a few questions while you were presenting. Let me just see, I'm reading them here from my little iPhone. The first one goes to Sulalit, and the question is, what is the percentage of the total lithium battery, for example, NMC, that can be recycled, and would it be possible to know the percentage that can be recycled on the levels of cells, modules, and packs? Sulalit.
Yeah, thank you for that question. That's a nice question, and I think it's a range of numbers that one can cite for that, depending on what kind of batteries they are. So in my opinion, it would be very difficult to say directly what would be those numbers. But one thing that can be said is that in terms of the existing industrial processes, by metal weight, around 50 to 55% by the weight of metals is already a number that is used within Europe for the recycling efficiency calculations. But if you're looking at, unlike the lead batteries, which are now 100% recyclable, the electric lithium batteries, the LIBs, there is the numbers vary quite a lot. So it's difficult to quote any exact number. But if you look at the targets set for 2030 within the EU reports, most of these numbers are ranging between 75 to 90%. For example, the NMC metals, one could optimally achieve 90% in that range. But for example, lithium, which is the least recovered in the existing technologies right now, is somewhere between 50 to 70%, I would say.
All right, well, thank you. I hope that answers the question. My impression was it certainly did. An additional question, Sulalit, just on top of that, are any of the development projects you were mentioning open for Austrian companies to join?
Yes, I think we are always looking for new industrial partners who would be interested in either working in some kind of reference group, understanding the processes. The LIBRES project is, however, kind of is an innovation project, so the IP is distributed differently. On the other hand, the new NTNU project we are just currently starting up. So yes, there is of course possibility for collaboration with industries.
All right, and we are happy, of course, to provide to our listeners the contacts so you can actually link up with Sulalit and his colleagues. A question goes to Frida, and it asks whether ESS, which supports fast charging systems, could be a solution to one of the problems you mentioned. They could also, our listener says, relieve the energy grid. Any comments on that, Frida?
Yeah, absolutely. I think, I mean, this will be part of the solution. And this is something that also SINTEF is working on currently. We have projects where we look at supporting the grid using energy storage systems. And I think also some, I know in, because a challenge in Norway with many of the ferries is that they are operating in very rural areas where the grids are not very strong. So when the ferry comes into port to charge, the local grid isn't strong enough to support the charging of the battery. So they actually have batteries at the ports, additional batteries at the ports that are used for charging the battery on board. So this is already something that's being used, and I think as also Kent mentioned in his talk, this will certainly be part of the solution.
All right, well, thank you. And there is a question probably which goes to Kent and refers to, well, a rather general question: what are currently the most widely used applications for second life lithium batteries for electric vehicles?
The primary use is basically ESS applications where weight and energy density isn't that important, because second life usage means you have to reduce the C rate or the rate of charge. So you have to increase the total volume of cells to be able to use it safely. Because that's the main reason why you can't use it in, for example, the car anymore. The internal resistance, the fluidity of the system, the ability to exchange protons has reduced so much that if you use the same load on the system, you get a lot of problems in regards to heat. But if you reduce the load, you can still use the cell for a very long time if you optimize the use pattern in and out for it. So typically the ferries that Frida mentioned, that would be an application for this kind of battery pack because the costs are so much lower than comparable system. Talking a fraction of the cost of a new comparable battery pack. I don't know if that answered the question.
I think it did, and if not, we are always, of course, able to maybe put questions, individual questions to you after the webinar, and we'll try to answer any additional issues you wanted to raise. There is a question which probably goes to Kai, talking about heat. There have been issues with electric car battery fires and the challenges of extinguishing them. How do you handle this danger on the ships you are or you will be using? Do you have an answer to that?
It's very difficult to answer for that for me, but we're working together with Kongsberg Maritime, that is the supplier of all the technology and battery in the vessels, and we have double systems on board in the ship. So it's I cannot explain the technology behind that, but it's double systems in the ships of battery and battery room.
Do any of the other
and I think
have an answer? Sorry.
They are using water to cool down the system.
Do any of the other presenters have an answer to that obvious risk of fires and batteries?
Yes, I can answer that. Hagal also has a subsidiary called Hagal Ocean that manufactures battery packs with new batteries for marine applications. And there's very specific and very stringent design requirements for these kind of battery packs to be able to certify them for use in vessels. So the fire safety is built into the technology, and the times where there's actually been a fire, it's not usually the cell that is the problem. The fires that have actually occurred so far in boats are due to faults in the electronics or fire outside of the battery pack that then puts the battery pack on fire. But typically a battery pack would have built-in multiple layers of safety, including fire suppression in Hagal's case. So the fire suppression is actually built into the battery pack. And during testing, you actually drive a metal spike through 3 cells on purpose to see whether or not it propagates. And to get the certification, you can't have any propagation. So the fire safety is built into the system, also with the one Kongsberg uses. It's a very good system.
Any more comments?
Yeah, I believe there are also quite strict requirements for the technical rooms where the batteries are actually placed, so that if you do have an event, a thermal event, then it has to be extremely bad, I think, for it to be catastrophic. And often I believe also that the batteries aren't necessarily all put in one room. They're often split into 2 rooms, so that especially the ones where you have fully electric, so that if you have one set of batteries that go bad in one room, you always have support in the second room, so you're not going to be stuck at sea.
Mm-hmm. Since you're there, Frida, it's not heat, but it's the cold temperatures. One of our listeners is raising as an issue, asking whether the cold Norwegian winters do affect battery life and performance, and is there anything that can be done to work against this risk and improve the performance in cold temperatures?
Yeah, absolutely. I mean, I think one thing that I always recommend people that ask me is that you don't ever start charging, for instance, your electric vehicle when it's -20 outside. You need to heat it up somehow, because you do affect, of course, the lifetime of the battery. And there are all electric vehicles have mechanisms where you preheat before you start driving. But the cold temperatures are obviously can be an issue. But once the battery is heated, so essentially once it's in use, the heat evolution in the battery itself is sufficient to keep it warm while you're driving it. So it's more when it's standing still and you're getting out to drive your car when it's -20 in the morning. You don't want to start driving it from a really cold car.
Thank you. A question probably best answered by Sulalit. Says here, you mentioned that many lithium-ion battery systems currently under development depend on scarce and non-renewable resources, for example, nickel and cobalt. Recycling is, of course, one solution. What is the current situation when it comes to developing batteries that are from renewable and sustainable sources?
That's a very nice question, and I guess Frida touched upon some of these batteries. I mean, we still need metals for the cathodes, I guess, or for at least large-scale battery production. But if in order to, so let's be clear on that the demand for new batteries and new technologies is primarily based on increasing the charge density, the time that you need to charge, and also extending the lifetime of these batteries. And all these factors would necessarily need different kinds of metal components. In terms of development of batteries that are kind of the next generation, I think there are sodium-ion batteries which one can think about. Of course, there are the solid-state batteries which are becoming very important, because then you are going away with the handling of the liquid electrolyte, for example. So there are lots of options, I would say. And maybe Frida, if you want to join in on that, on new technology.
Yeah, I can comment a bit on that as well. So, I mean, one thing that we've seen quite recently is also that these what's called the LFP batteries, meaning that you have the lithium iron phosphate batteries, are also becoming more popular. So, I mean, these have been on the market for quite some time, but because they have a bit lower energy densities and have been a bit more expensive, they haven't been preferred to the NMC chemistries. But now, especially Tesla is launching these in China for their electric vehicle fleet in China. And we are going to see a lot more, I think, of the LFP because they are also a safer chemistry than the NMC technology, and they have a longer lifetime. And in addition, you also have developments in especially the lithium sulfur batteries, which I think are also going to be coming eventually. So there's certainly other types of batteries that will be coming, and research, especially even for the type of NMC batteries, the research is going towards reducing or even removing the cobalt completely from the cathode. So other chemistries we will also see is what's called the LMO or LMNO, which is a lithium manganese or lithium manganese nickel oxide, which have a little bit different properties, but I believe we also see more of that type of chemistry in the future.
Wonderful. A more a question which relates to the development of truck fleet. Kai, for you, question is, are there any regulations, incentives, trends which favor the emission of the emission-free heavy-duty truck operation in the Nordics, and which critical milestones, our viewer is asking, do you see on the roadmap of truck electrification?
Yeah, I can try to answer that. We work with the truck like Volvo, Scania, and suppliers, and the main difficult things we have to have a solution for in Norway is the infrastructure, the charging systems in chargers in Norway, and I don't know if that answered the question, but
any input from the panel on this sort of? It's a very general question, of course. I mean, we've seen a lot of developments. I've only recently heard that I think it's a Stockholm-based startup called Volta Trucks is having assembled or manufactured actually its trucks by Steyr Automotive in Austria. So obviously also Austria is cooperating on, if you call that milestones, then certainly something that it is. If not, we leave it at that. Unless, is there an input? Yes. Kai, do you want to add to that, or?
No, I can wait with that.
All right, wonderful. Let me see whether there's anything else. Yes, there is a probably last question to Sulalit, referring to the lack of better sorting technologies. You mentioned what kind of sorting technologies are being used in Norway now, and is there room for improvement? And if yes, where would this lead?
I think most of the sorting that goes on now is primarily manual sorting, and Norway mostly crushes the batteries and produces some kind of black mass, but the black mass is not processed within Norway currently. So the thing is that on the sorting part, I was mostly referring to using some kind of a robotic system that would be able to spot the different kinds of batteries in the first place. If you're thinking of having different battery designs like Tesla batteries or Nissan batteries or other batteries coming in, that there is an intelligent technology that can help sort out the batteries based on design, and the second level of sorting where the batteries, after they are disassembled and opened up, they are separated based on chemistry, if that's possible. Otherwise, the route down the stream has to take into account the differences. For example, recycling an LFP battery from an MC battery will not necessarily follow the same route. So that was more or less the reason for mentioning that sorting requires quite a lot of incentive in terms of research and industrial interests.
All right. Well, thank you. I think we close the question and answer session with that. If there are any additional questions, as I mentioned before, please just send them to us. We'll be happily trying to provide you with answers, which of course would come from our experts. So thank you to all our panelists for being so informative and also for answering all the questions which were put at this time. I would just like to let you know that, as I mentioned before, you will all receive an email with a link, a YouTube link. This webinar has been recorded. For those who have not participated, of course, it's also an opportunity to view all the presentations. We've had quite a good number of attendees. See here, it's 80 participants, which is fantastic. So thank you very much for joining in. I think I also wanted to mention, especially for our Austrian companies, is that our Vienna headquarters has established a community platform called Energy for Mobility, and this community platform serves for Austrian companies to network with each other, but also to exchange ideas and to inform themselves on the latest trends in the field of mobility and energy, of course, with a very heavy focus on e-mobility. So this leads us to the end, and this is already the last slide, ladies and gentlemen, which I want to use to say goodbye to you. And again, thank you for joining. E-mobility, battery technologies, renewable energy sources is a topic which we are putting a focus on, especially here in the Nordics. The Nordic countries are investing heavily, and there's a lot of know-how, there are a lot of technologies around. And I mentioned an example before, Austrian companies are participating in these developments. So I think we can only solve these problems together. I hope all the presentations were inspiring for you to do more in this field. And as I offered before, please stay in touch with us and follow our activities either on YouTube channels, on our website, wko.at, or of course, by sending us emails. You have the email addresses here on this slide. Either send it to our Nordic Hub here in Stockholm or to our office in Oslo. We also have offices in Helsinki, of course, and in Copenhagen. So with this, I want to conclude this webinar. Thank our panelists, thank all the listeners and viewers. From me, Martin Glatz, it's thank you and goodbye.